Wang, and welcome to my final project. The goal of the project was to analyze the New York City crime data. Since it's a time series, I wanted to see if crime had trends and patterns and if we were able to predict monthly crime counts. I also wanted to see if temperature had a strong correlation with the number of crimes during the year, and if so, which type of crimes are most affected. And additionally, I wanted to create map visualizations to locate where and when crime is most concentrated. And lastly, I wanted to create a web app to bring more insight to users about crime data. Currently, I'm in Drexel's BSMS program in computer science. My skills are with Python, C, Java, software development, and database management. My contributions to the project are that I've processed the crime and weather data, performed EDA on them and created visualizations, and developed a web app. So the crime data was provided by the NYPD, and it provides every criminal complaint since 2006. There are almost 8 million rows, and to the right is a data dictionary. I provided it in the repository as well. And here are a couple rows. Some of the columns I've used is the complaint from and to date, the offense description, longitude, latitude, the borough, and precincts. Some other data I have was to create the borough borders. We see that on the left it shows the map of the borders, and on the right, we see it has it for Brooklyn, Queens, Manhattan, and Staten Island. And we have similar data, but for precincts, for police precinct borders. On the right, it shows tabular format again. Fun fact, there's no 99th precinct in New York. So the weather data is from a weather station in Central Park since 1869. It's from the National Centers for Environmental Information. The only fields we care about is the average temperature, precipitation, and snowfall, which you see on the right. It has no missing values. Also, the weather station is located in New York City Central Park. Here's an example of the data. It gives the monthly average temperature in Celsius, precipitation, and snowfall. So for stakeholder and use. So this analysis would be useful since police can respond to crimes more quickly, state officials can make better decisions for public safety, and where to send their resources. Organizations will know which areas need more attention and develop strategies to reduce crime. And residents can stay informed about crime patterns in their neighborhood. So first, I graphed simple line plots showing crime counts per year and crime counts per month. We see that crime is decreasing per year, except there's like a spike after 2020, which might be because of COVID. We see that crime per month goes up and down, and I think that's because of temperature, since there are fewer crimes near the end of the year and more crimes during the warmer months. But before I get into temperature, I was curious if I could just do like a linear regression to predict crime counts per month, but we see that it's a bad idea since the R squared value is like 0.31, which means it's a weak correlation. The root mean squared error also looks pretty high, 3,300. And after creating the residual plot on the bottom right, it kind of looks like the scatter plot above, but no downward trend, which is more proof since residual plots should be randomly scattered. But since the data is a time series, we should decompose it into its three parts: its trend, seasonality, and residual. Here we see downtrend, which is correct. The seasonality shows a consistent pattern of peaks starting in August and lowest in February. And residual shows what's left of the data. So instead of the linear regression model, let's try the Surima model. which is more tuned to forecasting time series data. However, we would have to figure out if the data is stationary, which means that its mean, variance, and autocorrelation are constant or at least close to it. We can use the augmented Dickey-Fuller test to test for that, and in our case, we initially see the data has a p-value of 0.74, which means that's not stationary, since we need a p-value lower than 0.05. So we'll have to apply some differencing to our data set, which just means subtracting the current month's value with the previous month's. And we see that if we test p-value differences, we get much less than 0.05, and we can tell our model to do one level of differencing as a parameter. So after creating the model, we see that it incorporates both seasonality and trend, since when we predict the crime count for future years, it goes up near the summer months and down near the winter months. There's also a downtrend, as we saw the linear regression also captured that. And to the right, we see a diagnostic plot to see if we captured all of the data. We see that there's a residual mean is around 0, and the KDE plot next to it follows the normal distribution closely, and the QQ plot also shows this as well. And this means that there's no other patterns the model could have missed. And compared to the linear regression model, the SRAM model also has it seems more accurate with a lower root mean squared error. Moving on, I wanted to see where crime was most concentrated. We see that these two maps are borough and precinct. Basically, the redder the area indicates there's more crime. In 2021, we see that for boroughs, Brooklyn has the highest count of crime, and for precincts, police precinct 75 has the highest count of crime. So let's explore what crimes are most common and when they occur most frequently. Here we see that petite larceny and harassment are the top two crimes in Brooklyn 2021. Petite larceny is just like small, non-violent theft, like stealing a wallet from someone's locker. To the right, I created subplots with crime count and different granularities. So crime counts per month, per week, per day, per hour. We see that there's the highest count of crime in October and crimes per month, and lowest in February. And it seems that the first of the month also is most common for crimes per day, and lowest is the 31st, which could be because not all months have the 31st day. And also, Fridays are highest for day of week, and Sundays being the lowest. And during the day, crimes are highest from 3 p.m. to 6 p.m., with lowest being from 4 a.m. to 6 a.m. Moving on, I also want to see how long crime lasted and how long it took to report to the police. In the histogram, you see that 94% of crimes last from 0 to 2.5 days. For crimes reported to the police, only 84% of crimes take 0 to 2.5 days to report. Of course, it differs case by case. For crimes that take almost a year to report, I found out that it relates to rape crimes or sexually related crimes. Moving on to weather, I want to see if temperature had an effect on crime count. For the average temperature, we see the peaks are during July, and the peaks for crime are around July and August. For the valleys, we see the average temperature and crime count near the end of the year, around November, December, and January. Therefore, there should be some correlation between temperature and crime count. There's also a field in the crime data to where the crimes occurred, like inside, in front of, or at the rear of an establishment. So here are two regression plots of indoor versus outdoor crimes. We see that the R squared value for indoor is really low. It's like 0.005, but for outdoor it's 0.63. Now, I also wanted to find out which outdoor crimes are most affected by temperature. So we see that assaults have the highest correlation, being 0.83, and one of the lowest is like intoxication, which has an R-squared value of 0.004. Therefore, it seems that crimes are definitely more affected by temperature than others. So some of the challenges I had during the project was getting the data. At first, I wanted to get the data through an API, but it only provided 1,000 rows per API call, and the data set had 8 million rows, so that's like around 3 gigabytes of data. So I had to download the entire data set, which took minutes to download and even longer to load it into Jupyter Notebook. So I had to convert it into a Parquet file and use PySpark to do data manipulation. I also the crime data had fields that were often missing, like information relating to the victim and suspect of a complaint. It would have been nice to create like a classifier, like who's more likely to be a suspect given the area and victim, or vice versa. The violation and police codes were also often abbreviated, so it's like really hard to figure out what the crime is sometimes. And now here's the link to the GitHub repository. So this provides all the code, the notebooks, the data, and a bunch of instructions of how to set up and take over the project if needed. And also have a link to the app, which is here. There's a little description of the project, as well as all the plots I showed in the slides, but they're more interactive. There's also explanations, and you can provide inputs of how far to predict in the future. And this is all hosted by Streamlit, so you'll be able to visit this website as well. And here, if you click on a row, it changes the plot, the regression plot to the right, based on the type of crime. And we also have mapping crime, so if you click a borough or precinct, it outputs this plot here, this map. And if you click on a certain area, it will update and show these plots. So top crimes in Brooklyn, different time granularities, and time duration and crime latency. And here's the about page. It's basically the README. Thank you.